We're about to start our science seminar, and before we do, I'll just remind you what a science seminar is. One of the most important things about a science seminar is that it's a place for you guys to share ideas. Today, students were engaged in a science seminar about what caused the extinction of the dinosaurs. This class was trying to determine which claim was better supported, either that the dinosaurs went extinct because of an asteroid or that the dinosaurs went extinct because of volcanoes. The teacher's role in the seminar is really to step back and allow students a place and a time where they can share their ideas with each other. It's been my experience that the most powerful science seminars are when I've been able to step behind the semicircles and just allow the seminar to come from the students. So you're gonna run the conversation. I am going to step back behind you. For the first couple of seminars, I spent extra time setting up norms for my students. If you're in the inner circle, you'll start the conversation, and outer circle, you'll be listening, and then you'll switch. So after about 10 minutes, you'll switch, so don't worry if you were thinking you might not get to be in the inner circle, you will. I usually stand behind students or off to the side when I'm running a seminar, and that's really so that students have a visual that I'm not the one that they're talking to, that they're really talking to each other. During the seminar, I'm an active listener, just like the students, and I'm taking notes, I'm listening for who is using evidence, who is explaining their evidence, I'm listening for the depth and the breadth of student science knowledge that they're bringing into the seminar, and I am also taking notes on how students are responding to each other. Are they building off of each other's ideas? Are they disagreeing and explaining why? Or are they being quick with their answers? And those are things that I can then talk about with them later. Long silent stretches are common when I've done a science seminar for the first time with students. And it's important to let that silence be there, I think, because if I jump in and try to push the seminar one way or the other, then already I'm taking it away from the students. Anyone can jump in who's in the inner circle. It's okay if there's silence as people are gathering their thoughts. But you don't need to be called on, so go ahead.
I think it says that since it faded out gradually, it is a evidence for the fact that an asteroid might have struck Earth.
I also hold back because I like to see if students can address misconceptions that their peers have brought up, which is also another really exciting thing to have happen in a science seminar.
I think that the evidence tells us that the crater, that the asteroid that they say in the claim could have hit there, but I don't think that it would have caused all the dinosaurs all around the world to go extinct. I think the volcanoes would have been a better choice, even though that there is proof that the asteroid probably hit in southern Mexico.
If an asteroid hit in the center of a big continent, it would have probably hit the land around it, and this asteroid was 10 kilometers across, so that was fairly big, plus the speed of it falling from space.
Well, are you talking about, do you think all the continents were like Pangea, or, because I believe that by then they already split up, didn't they?
Well, they were probably fairly close together.
Well, yeah, but because I think that maybe by then the continents would have split up far enough so that the asteroid wouldn't have gotten all the continents with the ash. I think that maybe the volcanoes were a better cause because the volcanoes would have been closer together.
But it doesn't say how many volcanoes erupted. It could have been 2 or 3.
But it does say that many of the volcanoes some of the volcanoes were erupting. Many of the volcanoes were erupting much more often than they normally do.
I really try to avoid interrupting, but sometimes I need to steer the conversation back to the claims. What does this card tell us about the claims? The force of the asteroid hitting the Earth was 2 million times greater than any nuclear bomb ever tested. What are your ideas?
It means that the asteroid had to be really big if it was 2 million times greater than any nuclear bomb that ever had been tested.
Well, it's either that or it fell with a really great force, because it did come from space, it was in orbit, and it was falling towards the gravity of the Earth. So it definitely would be extremely big, but it didn't have to be as big as like some huge amount of mass. It would be very big, but since it's falling fairly fast, then I think that would also contribute to the force.
Once I get the right balance between facilitating and stepping back, and the kids are really on board with participating and sharing their ideas and questioning each other, the science seminar can be really empowering for students. And I often notice that students surprise me with the things that they say, and sometimes the students that are participating surprise me. Ones that I wouldn't have expected to jump in are jumping in and sharing their ideas.
Other kids or people share their ideas, and it opens your mind to other possibilities.
To make the seminar a successful student-led discussion, there are a couple things that I keep in mind. Setting up the student-led discussion norms, allowing for long, productive silences. I avoid jumping in to correct student misconceptions, or if needed, I'll steer the conversation back to the claims.